Hey, Joe. Great to see you here, and we're excited to be talking to the audience today about the future of data engineering.
Yeah, let's get into it.
Yeah. But before we do, we're going to jump into our introductions. And so recently, Joe and I co-authored a book called Fundamentals of Data Engineering, which you may have heard of. We also, a couple of years back, co-founded a company called Ternary Data. And so that's kind of what led us to this project. And I'll let Joe introduce himself as well.
Yeah, I'm Joe Reis, the other co-author of Fundamentals of Data Engineering. I'm also a recovering data scientist, data engineer, architect, and podcast host. So Matt and I also, I guess, kind of co-host the Monday Morning Data Chat, which is a very popular weekly podcast that surprisingly you can tune in on every Monday. So.
Yeah, awesome. I think the most exciting thing about that is just getting exposed to a lot of ideas about what's going on in the industry. And that's how we're opining today about what the future might entail. Of course, no one knows for sure what's going to happen, but we see a lot of interesting trends right now.
Yeah, let's jump into it. So data engineering, the present, right? So it's to understand the future, you need to understand the present. So let's talk about the present for a quick bit. As of last year, this was the infamous data landscape slide published by Matt Turk over at First Smart Capital. I do not believe he has one for 2022, but 2021 was an exceptional year in the sense where the data landscape is insanely confusing. And as far as I know, this actually is a fraction of the total data landscape out there. Matt and I always joke that there's probably more data startups than there are atoms in the universe. And so here we are. There's, in a nutshell, there's a lot of platforms. There's a lot of technologies, whether open source or SaaS. And what this leads to is it leads to a lot of confusion in the data space, right? So if you're a data engineer, for example, how do you choose tools, right? How do you have a mental model to understand, this, just these thousands of technologies out there?
And I think part of what we're going to do in this talk and part of what we did in our book was frame this like massive plethora of different tools, right? Because if you want to understand the future, you kind of need to understand the present, like what we're really doing with data right now. And so that leads us into what hasn't changed, what's really stable. In other words, if I look at this crazy constellation of potentially, all the tools that Matt Turk has, plus all the tools that he hasn't even put in his graph that maybe aren't VC funded or something, what do these data tools really boil down to? And so this is kind of the framework that we came up with as we were writing about data engineering in our book, and I'll let Joe talk a bit about this.
Yeah, so I mean, when you talk about fundamentals, you're trying to focus on the things that aren't going to change as much, right? Of course, in technology, change is a constant, but if you kind of zoom out, the notion of data engineering, what are the building blocks of it, right? So for us, an easy book to write would have been, data engineering with, technology X, Y, or Z, or platform ABC, right? But we chose to really zoom out and understand, okay, so at the end of the day, if you were to pick up the fundamentals of data engineering and read it 5-10 years from now, what's likely to stay relevant? And so we came up with this notion of the data engineering lifecycle as well as its undercurrents. So when we're talking about maybe systems that generate data, for example, right? It's hard to imagine that systems aren't going to continue generating data. That would be kind of a showstopper for a lot of engineering and data projects. And of course, there's a notion of ingesting it and transforming it and serving it and storing it, and then and again, downstream use cases that use this data, whether it's analytics, machine learning, maybe reverse ETL, data sharing, and so forth, right? All these are building blocks upon which you can build, great data architectures, and in that data landscape, right? Like really decide what tools to plug in along this life cycle. But along the way, there's also the notion of undercurrents, things that also aren't going to really change in the data engineering life cycle. So things like security, for example, right? And again, a note on the slide, the lining of like security doesn't match with generation. The notion of the undercurrents is like something like security, fits into every component of the life cycle. Let's talk about security for a second, right? I mean, there's been a lot of popular or say infamous data breaches recently, and security should be top of mind for data engineers across the data engineering lifecycle. Same with things like data management, right? This includes data governance and all the aspects of data management, which itself is a very huge field, right? Data engineers should understand data management. Same with data ops, right? So how do you observe and respond to incidents that occur with both your systems as well as the data itself? A data engineer should also be able to architect systems. Architecture is one of these areas what Matt and I find kind of funny. If you were to talk to a person with the word architect in their title and ask them what architecture means, you'll probably get as many answers as you would people that you talk to. And so architecture is one of these things where a data engineer should understand the principles of architecting robust systems. You need to be able to orchestrate processes and tasks, both within components of the lifecycle as well as across the lifecycle. And finally, software engineering, right? Data engineers have the word engineering in the title, and a lot of the concepts of data engineering are at their core really borrowed from software engineering. And so all these undercurrents and all these components of the lifecycle we feel are immutable aspects of data engineering as a practice. Matt, you want to add anything?
Just the key idea that I think as we were writing the book, like the very early phases, developing the outlines, what we realized is these ideas cut across everything, right? Like data engineers need to be able to do these things, and they need to do them all the time, regardless of where they're working. Like we sort of tried to fit them under the stages, and then we're like, well, security doesn't fit under ingestion or transformation or anything like that. It's everywhere. It cuts across everything. Mm-hmm. So I guess the point is we're talking about the future too, is that for the most part, we expect that a lot of this stuff is going to stay the same, even though the technologies and techniques will change over the next decade, for example.
Right. And again, with life cycles, it's the thing to note about life cycles. It's not necessarily a linear progression. Some of these aspects may loop back on each other or flow in a somewhat of a meandering fashion. But in general, you have to get data from a source system and you have to do something with it and serve it for downstream use cases. That's essentially what data engineering is at the end of the day.
Yeah. Yeah. And it's really good to bring the focus back to that so people can focus on the essentials.
Right. Well, let's talk about the ongoing changes here, right? So there's a few of these we're going to touch on, I think relevant to the context of this event as well. So, some big themes that are changing, right? Enterprisey data engineering. What this means is a lot of the enterprisey practices that were once reserved for large enterprises, things like data management, for example, things like ops and things that you basically needed a large team and a large budget for. These are becoming more commonplace for data engineers that work at small and medium and large businesses as well. Data engineering is becoming more abstracted, and so the old days of the big data era where you had to manage infrastructure and manage complexity at a low level, that's gone away. If you're managing Hadoop in this day and age, or managing your own streaming platform, maybe you have a good reason for it, but most likely you're using kind of more abstracted off the shelf components. And then this leads to a democratization of tools, right? So much like the modern data stack in the 2010s ushered in a new era of cloud-based, SaaS-based, easy to use, modularized data tools, that basically eliminated the need to have expensive data warehousing, infrastructure. What we see is there's a rise of we feel like the next phase of data stacks and the progression of data engineering is really going to revolve around the democratization of streaming and real-time tools. Right now, if you want to stand up a Kafka or Pulsar cluster, you certainly can do that. It's not easy. There are companies that allow you to purchase a managed solution, but again, there's still a lot of underlying complexity and a lot of things you need to know. And so, democratization and simplification of tools is that's an ongoing change and will continue to be a change. That's inevitable.
Yeah, and I think that's going to lead directly into some of the big changes in the future. And so to add to what you were saying, Joe, simplification of tools. And I think you can also say that what's happening is we're getting into like second and third generation tools. So I think of Hadoop as being like the first generation big data platform, really complex to manage. You're dealing with complex programming languages, low-level programming paradigms like MapReduce. And now people have built on those paradigms, maybe not the same technologies, but those paradigms to make everything easier. And so now what happens with that next generation is impacts on business. And I want to add to what you were talking about with streaming. And this is the concept of the live data stack. And so the idea with the live data stack is that we see the democratization of streaming spread to the point where we see it in more and more companies becoming a reality. And we also see companies building pipelines instead of taking events that already exist and bringing them into a streaming platform. They're going to build entire platforms from application to analytics around the concept of streaming. So maybe you could add a little bit more to that and talk about this diagram some.
Yeah, I mean, the name of the game is speed, right? And so the modern data stack, I would say that the biggest contribution of the modern data stack has been that it democratized data warehousing. But that's very much a batch-oriented world. And the way things are going is streaming in real time will be a first-class citizen. I think that batch will very much feel like a dial-up modem, in a few years. It'll still have its use cases, but it'll feel increasingly antiquated. I mean, why batch things when you can stream them and get them in real time? There's definitely arguments for batch, but I would say there's more arguments in favor of streaming if you had the alternative, right? And so, but what this means is that this whole notion of a live data stack is the data engineering is going to move more upstream to the application and source systems. So it's possible that the line between a data engineer and a software engineer will increasingly become blurred, and there'll be a lot more ways for software/data engineers to incorporate event systems directly into the application itself. What this means is, things just move faster. The feedback loop between application and downstream use cases, it shrinks, right? And the feedback loop keeps tightening up and tightening up and tightening up. Reports become faster. You get more automation. So things that you traditionally do with reports, such as answering what or when type questions, those become automations. This allows analysts to focus on sort of why and more causal type analysis. Machine learning becomes more embedded into applications itself. And kind of sitting in between, you have low latency, faster query engines and databases that can capitalize on ingesting events in real time. So again, what does this mean for the future? It means that the time to value for data shrinks, right? And the live data stack is, or however you want to call it, in the future, we feel like this is the trend where data technologies are going and the workflows of data engineering. But there's more to this, and I think, Matt, do you want to touch on this next one?
Yeah. So I'm going to be talking some next on I call it the rise of unstructured data, right? It's not a rise and fall of something. What we're seeing is just an absolute explosion of unstructured data. And specifically, I mean video, audio too, but like video. Just think about what's happened with video during COVID and pre-COVID. And it's funny because video has been big now for maybe, when did YouTube start? It's been quite some time now. Video just keeps
decades,
growing from strength to strength. Yeah, it's been a while, but yet we keep growing in video. People are generating massive amounts of video from their phones, user-generated content. They're posting on TikTok and YouTube. They're sharing with their friends. And so we think that this is going to become part of a hybrid of ML engineering and data engineering in the future.
Mm-hmm. Yep.
It's such a big trend that no one can ignore it anymore. And I want to talk a bit about the state of the situation today. So right now, again, explosion of video content. What do you care about in that video content? Well, a lot of things, but more immediately, we tend to care about language. Like, what's the language in that video content? What can we do with it in terms of NLP? And so typically in data pipelines today, what we do is we transcribe audio data off of video, we generate text data, and then we pass that through various text-based NLP processes. And there's another thing we do, which is if you go to Facebook or you go to Instagram, for example, we still care quite a bit about what I'm going to call human-generated labels. And so these are things like likes. So I'm on Instagram, I hit the heart button, I like a video. That tells data engineers and data scientists, hey, this video is interesting to this particular user. Maybe it's interesting to other users. What are some other examples of human-generated labels? Well, clicks. If I click through, if I watch, I can think of that as a label, right? If I spend a lot of time on a video, that's kind of labeling that video as interesting. And then comments. So even more textual data. When people comment on there, that gives data scientists something to work with. So there are a couple of trends, one to do with real time and one actually to do more with deep learning that I'm going to talk about. And this is, again, a bit more pie in the sky, but I think we see it coming down the road. First of all, on here, this media is going to become less textual. So what I mean is that eventually we'll get to the point where we're not relying on the intermediate of text to understand the language and data. So think about how you understand as a human a YouTube video. I go to YouTube. Sometimes I might turn on the subtitles, but often I just process that audio data with my brain without ever passing through text. And that's organically what humans have been doing for thousands of years. And so I think in the future, we're going to get to a point where deep learning starts to be able to do the same thing. And so that's where this bottom bullet point comes in. Rapid improvements in deep learning-based approaches, they're going to start to blur into aspects of data engineering. So this is what data pipelines look like today for video and audio content. Take it in raw content, we transcribe it first, as I mentioned, and then maybe we do some other text-based things like object recognition, where I output text labels, and then my data pipelines from there process that textual data to make sense of it. And so I think in the future, what we're going to see is two trends. First of all, this deeper analysis that doesn't pass through a textual intermediate. So for example, I can have a deep learning model watch a video and tell me something about the sentiment without going into text first. Maybe you can tell me something about the quality of the acting or the emotion expressed by the person in that video. That's batch. And then on the non-batch side, what I expect is that we're going to see even more transcription, but in real time. So instead of transcribing NLP data and passing it to models in batch, we'll start feeding that into real-time pipelines so I can get an idea of what's going on in a video in real time. And then maybe if there's violent content in that video, I can respond very quickly by cutting off a live stream. Maybe I can surface that video to users who might be interested based on the textual data that I'm getting in real time. But I think in the end, so this will start with social media, but in the end, it's going to bleed over into data engineering. And that's because the amount of video that we produce is going to be so important that it's going to seep into other parts of the work of data engineers. So for example, we'll probably start producing more and more video inside of companies. And so now data engineers are going to have to start thinking about that and collaborating even more with ML engineers. And so for certain types of engineering, we'll see this hybridization of machine learning engineer and data engineer. Now, I should say here that that's not to say that other types of data engineering are going to go away. So for example, we're always going to need to do things like accounting, right? Your financial data needs to be correct. Sales data needs to be correct. Things like data modeling still have to be done and still have to be correct. Data structures have to be correct. It's just that the job of data engineering is going to continue to expand into new domains as the explosion of data continues. And then again, big trend here, democratization of real time. Just as Joe said, we're going to see real time getting involved in application pipelines from the beginning of the application and from the inception, and then more and more sophisticated media processing that bleeds over into the job of data engineers. Anything you want to add to that, Joe?
No, I think it's great. The other thing I'm personally excited about is stable diffusion and related type of models.
Yes.
I think that's also portends a very interesting future for machine learning and for data engineering.
Yep.
So,
and that's just it. I think from my perspective, we see things like stable diffusion and GPT and DALL-E, and this is really just the beginning, right? Yep. And so that's where the job of data engineering is going to be so complicated in the future, because we will increasingly need these crossover skills to be able to handle a world of not just unstructured data, but really media data that humans are generating, basically. Yeah.
Well, cool. Well, thanks everybody for joining the talk. Here's how you can find out more about Matt and I. So,
yeah, and please feel free to reach out to us on a variety of platforms. And it's been great to record the session, and we look forward to interacting with everyone in a variety of ways.
thank you.